Hi guys, this is a video over your quiz that you took in geometry. Since I haven't been able to be at school, I wanted to go over this with you. So um, I actually have a typo. I had a few typos, as you noticed, but number one here, I didn't count it against you because I had a typo where I wrote it as if P then Q is true, then P then R, which totally doesn't even make sense. But it should be then Q and Q then R is true, then P then R is true. That would be the law of syllogism. So A is correct after you've changed the question a little bit. So I didn't mark anybody off this one because everybody had different answers because none of them are really quite accurate. Number two here, if we're reading this statement, this given and the conclusion, and we're asked to decide what kind of law is being used to determine this conclusion, let's take a look at what we have here. If an angle is acute, then it is not obtuse. Angle A is acute. So the conclusion is angle A cannot be obtuse. So if it was the law of syllogism, then we would want to see that repeating statement. And so that then statement would be repeated as our next statement made here. So if it was law of syllogism, it would be something like, if an angle is acute, then it cannot be obtuse. If an angle cannot be obtuse, then it is something else, right? So here the conclusion is based off of what's said here, angle A is acute. Notice how when you're looking at this statement, angle A is acute, that's saying the same type of statement as the hypothesis in the given. And so the conclusion is also saying the same type of conclusion that's in your given statement. So the answer for this would be the law of detachment. So you're detaching the statements. If blue, then yellow, and then here's a blue statement, then my conclusion is yellow. Okay, so that's one way to look at it. If you were looking at the law of syllogism, what you would see is, I'll use colors. So if yellow, then blue, and if blue, then green. So I can conclude if yellow, then green. That is the law of syllogism, okay? But the law of detachment is just saying an if-then statement, and then you're coming up with a conclusion based off of an if statement that also mirrors the initial if statement. So I don't know if that makes sense, but hopefully that clarifies that a little bit for you. And then number three, what best describes the statement a plane contains at least 3 points not on the same line? If you look at your postulates, that is one of your postulates that we wrote down in your notes. This is always true. A plane always has at least 3 non-collinear points. So 3 points that are not on the same line. Number 4, what is the type of proof where you write a paragraph to explain why a conjecture for a given statement is true? A paragraph, that one is pretty straightforward. It's a paragraph proof, okay? All right, let's take a look at your proof here. I did grade number 5, and then I've adjusted number 6 to just do it with you as a review, even though you didn't do it on the quiz, okay? So number 5 here, we have the initial given, which is just the equation. And so our reason is that it's given. And then the distributive property says I need to distribute my -3 into the parentheses. So what I'd have now is -12x minus 3 equals 21. Okay, so how did I go from -12x minus 3 equals 21 to -12x equals 24? Well, didn't I just add the 3 on both sides? And since I'm adding, that's the addition property of equality. So property of equality, okay? And then finally, how did I go from -12x equals 24 to x equals -2? Well, didn't I just divide on both sides? So that's the Division property of equality. Okay, most of you guys got this one just fine. So whenever you're looking at algebraic proof, you're probably going to use properties that relate to solving algebraic equations like addition, subtraction, multiplication, division, that kind of thing, right? And then down here, let's take a look at this one. So the given is that Q is the midpoint of PR. So Q is the midpoint here. And R is the midpoint of QS. So we're trying to conclude that PR and QS are equal, okay? So what's given here, I'm gonna write Q is the midpoint of PR. And then looks like they've made a conclusion from that statement of PQ equals QR. So how did they conclude that PQ is the same as QR? Well, if we're looking at linking these two statements together, Q being the midpoint tells me that those two parts are equal. And so this is a statement that's made because of the definition of midpoint. Okay, then the next statement there, the reason that's given is the given. So I have another given that I didn't write down. R is the midpoint of QS. That's just given to me. Okay, so as you're reading the next one, next statement there, why do you think they came up with a conclusion that says QR equals QS? Well, it's going off of this given. So let's take a look. QR is congruent to QS. Let me use a different color here. So QR is equal to QS. Well, I know that because R is the midpoint, right? I know that those are congruent because of midpoint. So I'm going to say the definition of midpoint again tells me that. Okay. PQ equals RS. Where did this come from? So this is a new statement. Let me highlight this. Where did this statement come from? So whenever I'm looking at this, I need to think through what statements have been said earlier. So I've got a statement here, got a statement here. How can I relate these two yellow statements to this green statement? So if I look at this, PQ is right here, RS is right here. If I read these two yellow statements side by side, like PQ equals QR and QR equals RS, what can I conclude from this? Well, I can conclude that PQ equals RS, right? What kind of property is this whenever I'm skipping that middle step? Now, it's not the law of syllogism because remember we talked about we don't use the law of syllogism in proofs. This is the transitive property. Transitive, spelling it all wrong, am I? Oh, let's go back down. Transitive property. Okay, so now let's see if I have any connections from the statements that appear. Okay, so PQ equals RS. Well, I have PQ and RS right here. So if I look at this, think of my new statements always come from statements that are stated earlier. And so I can't just whip this out of thin air. I have to have some logical connection from previously made statements to make new statements. So if I look at the connection here, it looks like that I've got PQ equals RS, but I'm adding QR to both sides. So what property is it when I can add the same thing to both sides and those two things that are equal to each other would still remain equal? That is called the addition property of equality, right? So this would be the addition property of equality. And then looking down below, I've got if PQ plus QR equals PQ and QR plus RS equals QS. Okay, so where did this come from? I'm gonna use a different color here. So I've got PQ plus QR equals PQ. So I think this should actually be written as PR. I think that's a typo there. So this is PR. That should be PR. So so what I'm looking at is if I have, I'm gonna use blue here, PQ plus QR equals this entire thing, right? PR. That is what we call the segment addition postulate, right? When you add two segments together, it equals the whole part of that segment. And then we look at this again. QR plus RS equals QS. So see how Q is here, S is here, and R is in between? That's saying I've got QR plus RS equals this entire thing. So that conclusion is made because when I know I add two segments together, that equals the entire segment. So this is called the segment addition postulate. Okay. So then on the final thing, of course, my end statement is always going to be restating what's said above, PR equals QS. And the reason is substitution, and that is because if I know that, it's getting messy here, but if I know that PQ plus QR equals QR plus RS, and I've got PQ plus QR is the same thing as PR, and then QR plus RS is the same thing as QS, then I can replace these equal amounts for PR equals QS. So I'm substituting that equivalent amount in and restating that. All right, so that's your quiz that you did. You should also have worked on the review problems in class with your classmates. You guys can collaborate and work on that together. If you have questions over those problems, just send me a message. I'm sorry I'm not there to review with you in person. I really wish I could be, but at least you know the correct answers for this quiz. So review this quiz, review the previous quizzes that you've taken. So I think the quiz was over 2-1 to 2-3. Go over that old quiz that you have, and then if you do all those things, do the book work, review the quizzes, and maybe look over your study guides, I think you should be good to go. All right, good luck. I'll see you on Friday.